YouTubers, welcome to the Cyber Overwatch channel. I am Pragmatic1. In this video, I will be doing a walkthrough of HackTheBox's vulnerable host business. I will deliver a comprehensive walkthrough covering every phase from reconnaissance to post-exploitation. This will include detailed steps on port scanning, service enumeration, authentication bypass techniques, exploiting server-side request forgery, achieving remote code execution, and performing privilege escalation. If you find this content informative and you are interested in cybersecurity, please like and subscribe to the Cyber Overwatch channel. Also, for more free content, please regularly check back on www.cybersec.com. Bizness is a vulnerable host created by Carmelo to help users hone their ethical hacking skills. This host is available through the HackTheBox virtual training lab, providing a hands-on environment for practicing various ethical hacking techniques. I launched the target host business and confirmed it now has an IP as displayed on the screen. The first step in the process is information gathering, which involves conducting port scans and performing service enumeration. For active information gathering, I typically rely on nmap. I'll execute the nmap command shown in the CLI to identify open ports on the target host. To ensure no ports are overlooked, I'll perform a comprehensive scan of all 65,535 ports using the -p-switch, which is crucial for detecting services running on non-standard ports. Upon reviewing the nmap scan results, I identified 4 open ports: port 22 SSH, port 80 HTTP, port 443 HTTPS, and port 32991 TCP wrapped. Bizness appears to be a Linux-based host, as indicated by nmap. Nmap identified the operating system and CPE as a generic Linux distribution. Additionally, the SSH service is running and its banner mentions Debian. Next, let's investigate port 80. Examining the nmap output reveals that the web server is Nginx version 1.18.0. The banner also indicates a redirection to https://business.htb/. Browsing to http://10.129.51.46 results in a server not found error, with the address bar redirecting to https://business.htb/. This indicates that the host name needs to be mapped to the target's IP address in my system's host file. Executing the following echo command allowed me to append the hostname/IP to the host's file. Adding the hostname and IP to the host file allowed my system to resolve the IP to the hostname. This enabled me to view the business website successfully. I'll use the fuff command shown on the CLI to enumerate the web server and discover any hidden files or directories. The -u flag specifies the target URL. The -w flag provides the word list to use for the scan. The -r flag ensures the redirects are followed, while the -fc flag excludes results with HTTP 403 status codes. The initial fuff scan generated a significant amount of data, primarily consisting of 200 OK responses. On the following fuff scan, I did observe that most of the responses shared the same size, 27,200 bytes, word count 9,218, and line count 523. Notably, there were a few responses with distinct sizes, word counts, and line counts, which stood out as shown in the CLI. I decided to run the following fuff command shown in the CLI that would export the results to a file called fuff_output.txt. I ran the following cat command to verify the contents. As shown on the CLI, the output shows the fuff findings. After reviewing the fuff results, I needed to filter out the noise. To do this, I used the following grep command as shown in the CLI. The -v option inverts the match, meaning grep will select lines that do not match the specified pattern. The -w option ensures that only lines containing the exact number 9218 are matched. The -E flag treats the pattern as an extended regular expression. The pattern open parenthesis 9218 close parenthesis specifically searches for lines containing the number 9218. The input file fuff_output.txt is where grep searches for the pattern, and the operator redirects the filter output to a new file called fuff_update.txt. After filtering out the unnecessary data, I used the cat command as shown in the CLI to display the remaining viable pages for further investigation. As shown in the CLI, the filtering process reduced the list of pages to just 16. Browsing to the first page on the list titled Marketing redirected me to a login page. The page identified itself as OFBiz, developed by Apache Foundation. I then attempted to browse to various directories including /content, /catalog, /AR, /AP, /eBay, and /SFA, but each one also redirected me to the same login page. On the bottom right corner of the login page, it shows that the OFBiz release is version 18.12. I also display it in the page source. This should help me tailor my search for an exploit. OFBiz is an open source ERP system developed by Apache and tailored for large enterprises. It provides an extensive suite of applications for automating and managing business processes across various departments. Some of the modules available include accounting, CRM, content management, e-commerce, human resources, manufacturing, order management, project management, and supply chain management. When I browsed to /e-commerce, I received a different message. It appears to be a default message when OFBiz e-commerce applet is not configured. Browsing to /control page displayed a 500 server error. Browsing to the /webtools page appears to leak admin credentials for the OFBiz web application. Doing some research, I noticed that the Apache OFBiz project page documented the default admin credentials on the page as username admin, password OFBiz. I attempted to log in with the credentials documented on the webtools page. Entering username admin and password OFBiz, I received an error message as displayed in the browser noting that the password was incorrect. I performed a Google search for Apache OFBiz 18.12 exploit as shown on the screen. Searching for Apache OFBiz 18.12 exploit led me to CVE-2023-49070 and CVE-2023-51467. I came across an excellent write-up that thoroughly explains Apache OFBiz, the specific vulnerability, and the steps involved in exploiting it. Returning to the Google results, I selected User Connecting's GitHub page containing some exploit code. Reviewing the README page on the GitHub repository, it appears like the exploit is very similar to the write-up I had just read. I can download the exploit code by copying the git URL. Using the git URL I had just copied, I ran the git clone command shown in the CLI to successfully download the git repository to my system. I changed directories to downloaded repository and ran the ls-la command as shown in the CLI to verify that the files downloaded successfully. I need to review the exploit code to get a good understanding of what it does. I'll run the nano command shown in the CLI to open the script in the text editor. When using exploit code from an external source, it is always a good idea to review it for hidden malicious code. Let's break down the exploit code and see what it does. The script is written in Python and is designed to exploit a vulnerability in Apache OFBiz. Upon execution, it imports several essential libraries including base64, OS, requests, subprocess, system, and URL lib3, which handles tasks including encoding, making HTTP requests, running system commands, and working with URLs. Some key global variables are defined, such as usage_msg, which provides instructions for usage, auth_bypass, ping_test endpoints, which are used to bypass authentication and test connectivity. The HTTP header content-type is set to application/XML. To minimize unnecessary alerts, the script also disables SSL warnings from URL lib3. The generate_rev shell function creates a base64 encoded reverse shell command, while the generate_XML_payload function produces an XML payload designed for remote code execution. The RCE function sends the XML payload to the target URL in an attempt to execute the payload. If the exploit is successful, the function confirms execution. Otherwise, it prompts the user to verify the results manually. The shell function facilitates the reverse shell connection by parsing the target IP and port, generating the reverse shell payload, and executing it through the RCE function. The main function orchestrates the exploit execution by first ensuring that the required ysoserial-all.jar file is available and validating the target URL format. Based on the specified action, it then calls either the RCE or shell function prior to launching any exploit. The check_vuln function verifies the target's vulnerable by sending a post request to the ping_test endpoint and checking for a Pong response. In order for the exploit to work, I will need to download the ysoserial jar file as noted on the GitHub page. With the ysoserial jar file downloaded, I can now proceed with preparing for the execution of the exploit. Based on the usage_msg in the global variables section of the code, I can see that Python 3 needs to be used along with the syntax required. Before I attempt to execute the exploit, I started my netcat listener. I will execute the following command shown in the CLI to run the exploit script against the business URL. This should generate a reverse shell. If successful, will connect back to my netcat listener on port 1234. I ran the exploit, but it seems to have encountered an issue. Upon reviewing the output, I noticed it mentions an issue with Java, and it provides a command to resolve the error. I executed the following Java command to check the version of Java. The output indicates that Java 17 is installed, which, according to the error, is incompatible with the exploit. As noted in the error output, I ran the first command to install OpenJDK OpenJDK 11. Based on the output, it appears Java 11 is already installed. I ran the second command that was recommended. It required me to select the version of Java to use. I entered 1 to select Java 11. I ran the exploit command, and the output notes that the target host appears to be vulnerable. It also advises me to verify whether I got a shell. Checking my netcat listener, it appears that a shell connection was successfully established. The output confirms a session was created with the target host displaying the OFBiz user account and the current directory set to /opt/OFBiz. Based on the output, running the whoami command, I confirmed that I am logged in as the OFBiz user. I ran the pwd command to verify my location as the /opt/OFBiz directory. Finally, I ran the ls-la command to list the contents of the directory. I'll need to review these files for potential sensitive data, but I'll come back to that later. Now that I have a foothold on the target host, I need to conduct some host enumeration. I ran the cd tilde command to navigate to the OFBiz user home directory, followed by ls-la to list the contents. In the output, I discovered the user.txt file, which contains the first flag. I ran the cat command on the user.txt file to view the contents. With the first flag in hand, my next step is to escalate my privileges in order to locate the second flag. One of the most efficient ways to identify potential escalation paths is by running psng, whether it's on Linux or Windows. If for some reason psng's isn't available or viable, it is possible to fall back to manual enumeration methods. To start my host enumeration, I need to transfer over linps to the target host. To do that, I first started my HTTP server running the command shown in the CLI. After running the wget command, I can see that linps uploaded successfully to the target host. Based on past experience, linps more than likely does not have execute permissions. I used the chmod command shown in the CLI to set the execute bit on linps. I then ran the ls-la command, which confirms that linps is now executable. I executed the following command shown in the CLI to run linps. I included the -a flag for a comprehensive set of checks, and the -e flag for additional enumeration. This approach ensures a more thorough scan of the target host for potential escalation paths. In the Executing Linux Exploit Suggester section, several potential exploits are suggested based on the information gathered from enumeration. Before going that route, I will conduct further enumeration to gather more details. Looking at the writable logs section, it showed that OFBiz was running Derby and that the logs were writable. Reviewing the Apache OFBiz technical documentation, it notes that OFBiz by default runs a Derby database. Doing more research, I did find some information describing common Derby directories and what they hold. I changed directories to /opt/OFBiz. I ran the find command shown in the CLI to check for the presence of a Derby folder. The output confirms that a folder named Derby exists. I ran the command shown in the CLI to change directories to the Derby folder and to perform ls-la to view the contents. I manually reviewed the OFBiz logs, and I was able to confirm that OFBiz was indeed using Derby as the database. The Apache Derby documentation lists several common directories used by Derby, one of which is the seg0 folder. The documentation mentions that this folder contains user table information which could be of interest. I ran the find command shown in the CLI to locate the seg0 folder. The output revealed 3 seg0 folders. I chose to review what seemed to be the primary folder, OFBiz, for further examination. Changing directories to the /OFBiz/seg0 folder, I then ran the ls-la command shown in the CLI to view the contents of the folder. The output shows way too many DAT files to look through. To estimate the total number of files in the folder, I ran the command shown in the CLI. The ls command lists the folder contents, while the wc command performs a word count. Based on the output, there are 5,406 files in the folder. To narrow down the number of files I need to review, I ran the following grep command, as shown in the CLI. To search for any DAT files containing the word admin, the output indicated that 22 files matched my search criteria. I also attempted to search for other keywords, but none yielded useful results. Going back to the list of DAT files, I reviewed all the files grep pulled admin from. One particular DAT file contained a username admin and a SHA hash, as shown in the CLI. I attempted to identify the hash using hash ID, but it was unable to identify the hash. I checked Hashcat's examples wiki page, and I couldn't identify the hash from the page either. Based on the hash, it appears to be SHA-1. Doing some more research, I was able to confirm that the Derby database hashes the passwords with SHA-1, based on the Apache Derby documentation. I googled Apache OFBiz password cracking and came upon this GitHub repository, Apache OFBiz SHA-1 cracker by DuckSec. I ran the following git command to download the SHA-1 cracker repository. After downloading the hash cracking tool, I'll run the following command shown in the CLI. The hash cracker has completed. The output indicates that the tool successfully cracked the hash, revealing the password as monkey business. The first thing I'll attempt is to log in as root. I'll run the following command shown in the CLI to switch users to root. Running the command, I get prompted to enter a password. I'll enter the cracked password. When I typed whoami, the output confirmed that I had successfully switched to the root user. I ran the following command in order to get a full TTY shell. Once entered, it showed the prompt with the root account and the current working directory. I ran the cd tilt command to change directory to the root account's home directory. I ran the ls-la command to show the contents of the folder. Looking at the output, I can see the root.txt file containing the final flag. I ran the cat command on the root.txt file to display the hash. With that, I have completed the host. In conclusion, by employing a range of techniques, I successfully progressed from reconnaissance to gaining root privileges on the target host. Through these steps, I was able to collect the necessary information to establish a foothold on the target via authentication bypass and server-side request forgery. Once I gained access, further enumeration led me to an effective escalation path, where I cracked the database hash to ultimately obtain the final flag. Thank you for tuning into this demonstration of HackTheBox's Bizness Vulnerable Host. Thank you for also checking out the Cyber Overwatch channel. If you find this content informative and you are interested in cybersecurity, please like and subscribe to the Cyber Overwatch channel. If you have any questions, please feel free to leave a question in the comments, or you can send me a message from the CyberSec website listed in the description. Until next time, keep learning. The only way to improve is to keep learning. Pragmatic One, signing off.